Hello, this is module 14, and it is about transporting. So, of course, the layers that we've been covering. So, we started with physical data, link, then network. Now, this is transport. It's transport. So the areas or what you're going to cover: transportation of data, TCP overview, UDP overview, port numbers, TCP communication process, reliability and flow, then UDP communication. So the main objective is to compare operations of transport layer protocols in supporting end-to-end communication. So transport layer is responsible for logical communication, communications between applications. It is responsible for logical communications between application running on different uh, uh, hosts. So the link between, or the transport layer, it's link between applications, application layer, and then the lower layer that are responsible for the network transmission. So the lower layer, of course, since it's between, now this is transport, then it means upper layer we have the session, presentation, and then application. Lower layer we have network, we have data link layer, and then we have the physical. So for it is in between, and it is used to the transport layer. It moves data between the applications on devices in the network. So when it comes to the transport layer, it's the bridge now, bridging the data uh, between the application, of course, on a different network. So the transport layer, has the following responsibilities. It is responsible for tracking individual conversations. Individual conversation. That's a reason why if you chatting, maybe for example, like chatting on the Facebook, you can't accidentally find yourself chatting on the Gmail. So with the help of the transport, segmenting data and then reassembling data, that at the time when the data from the source it segments the data, then when it comes to the other side of receiver or the destination, that segmented data is reassembled, uh, uh, the reassembled, eh, reassembled back to get the other whole data that was sent. And then it adds header information. In header information, there is source port number, uh, then destination port number there. Serial 2 uniquely identify the application that are in use. So identify and then separate and manage multiple conversation. Multiple conversation. For example, you having, I can use the web browser, and then with tabs, and each tab connecting to different destination. Uses segmentation and multiplexing to enable different conversation to be interleaved on the same network. What we have here, these are segments, as you can see, but this segmentation allows conversation multiplexing. So in this multiple application, they can use network at the same time. So all these tabs, as you can see, they are interleaved. They are interleaved. Uh, they are interleaved. Uh, they are interleaved on the same network, not just to fast one application use the network, and then once it's done, then the other one comes in, and then no, all of them, they have equal rights on the shared media. So transport layer protocol, so IP, because now we're bringing in IP, but IP it's not a protocol in the transport layer, or it's not a transport layer protocol. So IP does not specify how to deliver. That is what we saw yesterday, that uh, with IP, it's connectionless protocol. Its work is just to logically identify the device. How the device is going to uh, uh, work, how it's going to be used, the network, how it's going to access the network, it's not its responsibility or its role, the IP. So now IP does not specify how the delivery or transportation of packets take place. Transport layer protocol specifies how to transfer messages between hosts and then are responsible for managing the reliability. Now in reliability, we expect like the conversation to all the sent the conversation, they should be received on the other side, they should be rearranged in case they are out of order. That is managing reliability. Transport layer, it has two protocols, TCP and UDP. Uh, this transmission control protocol, user datagram protocol. So there are the two. So at the transport layers, you can see only two. So these other protocols, they can actually specify which transport protocol to use. There are those ones that use TCP, there are those ones that use UDP. And all this, whether it's TCP or UDP, they have to use protocol. It's a must because the protocol, IP, it's like the foundation. All they have to operate on an IP. So TCP provides reliability and flow control. Now we are on the TCP or transmission control protocol overview. So it numbers and then tracks. It's responsible for numbering and then tracking data segments transmitted to specific host from specific application. So the segments that are sent, they are numbered and they are tracked to see whether they have reached reached the destination, or whether the destination has received those sent segments or not. Then we have it acknowledges received data, whatever that has been received, it has been acknowledged, then retransmits any acknowledged, whichever that is not acknowledged, then it has to be retransmitted. Sequence data that might arrive in wrong order, that is rearranging. Because these segments, they are numbered 1, 2, 3, 4. So if they reach the other side 4, 1, then 3, something like that, out of order, they are sequenced or they are rearranged. Send data at an efficient rate. The transport, they will have to, because with TCP, that before packets are sent or data is sent between source and destination, that the link, the connection has to be established. So in that process of establishing the connection, then there are even other requirements that are considered, or factors that are considered, like on the rate, the data rate to be exchanged. So the two, they have to agree on the data to be shared. Then we have overview of the user datagram protocol. It provides basic functions for delivering datagram between the appropriate application. So with very little overhead and data checking. So UDP does not check, it does not, actually most of what is done in TCP it's not done under UDP. So UDP it's a connectionless protocol. So for it, it just sends. Just sends. If it receives or there is a need to send, it sends. It's not going to establish the connection. There is no need of like agreeing on the data rate to be exchanged. There is not like numbering. Okay, now numbering it's there, but what is not there, acknowledgement and then uh, sequencing, like rearrangement. They are not there under UDP. So UDP is also used by request and reply application where the data is minimal and retransmission can be done quickly. So if it is important, that all data arrives and that it can be processed in its proper sequence, then TCP is the one to use. So where there is a need that all data it has to reach and then the proper sequence be done, acknowledgement be done, then TCP is the best protocol. So here we have the groupings. We have UDP and TCP, and then the most applications used there, we have voice over IP, DNS, and then when it comes to TCP, the more common simple mail transfer this, and then the required protocol properties. Now with this one here, it is fast because the way to receive that is how it's going to forward it. Little overhead. There is no need of checking, sequencing and blah blah. Does not require acknowledgement. Does not resend lost data. Delivers data as it arrives. So requirement for TCP, it's reliable. It's reliable that the connection it has to be established first, then agree on the data rate to be sent, then acknowledges data. If it receives, then the whatever that has been received, it has to be acknowledged, then resends lost data. The data that has not been received, it can be resent, then deliver data in sequenced order. So if it's 1, 2, 3, 4, and then the other side you have 4, maybe 1, 2, 3, they're going to be rearranged or reordered so that you have 1, 2, 3, 4. So the overview here, the features of TCP establishes session. First, TCP it establishes the session, the connection, ensures reliable delivery, reliable delivery. That all that have been sent, they have to reach there. So in this, it's because when you look at this thing, TCP it's a connection-oriented protocol, negotiates and establishes permanent connection or the session before source and destination. Destination devices prior to forwarding any traffic. So reliable, responsible for segments to become, it's possible. So if the segments are collapsed, lost completely on the transit, then they can be resent back, they can be what, even acknowledgement, it's within the data rate, so there. Then provide same order delivery. Yeah, I've explained that 1, 2, 3 segments. Still the other side, if it receives 3, maybe 2, 1, then they can be rearranged before it is presented. Then support flow control. Network hosts have limited resources. For example, memory, processing power, the storage. So when TCP is aware that these resources are overtaxed, then it can request that the sending application reduce on the rate of data, to reduce, and then the sending device starts sending small portion or less than what it was sending at in the TCP is a stateful protocol, which means it keeps track of the state of the communication. TCP, it tracks whatever that using TCP protocol. So TCP to records which information it has sent and which information has been acknowledged. I've sent 1, 2, 3, but 1, 2 are acknowledged, but 3 is not acknowledged. Then automatically it has to. So this is the TCP header. What is the fields that are in the header? But mainly TCP. So we have source port, destination port. These are very crucial to identify the sending application here and then the receiving application. Sequence number and acknowledgement number, they are the same because the sequence, it has to the segment 1, 2, 3, and then the acknowledgement. Then we have the links, header, links, reserved. Now the reserved, the reserved in case for optional, in case there is a need for that bit, for those the optional information that is needed, then of course it has to use the reserved. Then control bit, we have window, the size now, the size of the frame to be sent to the other side. The checksum for error, then agent. Now the agents of the the agents of the uh, the agents of the data or the message that is being sent. So we have optional options that there, application layer data, the size still varies. Application layer data size varies. The size of the entire um, data, or the yes, of the entire data. So here these are the fields with their descriptions. The agents field used to indicate if the contained data is urgent, then checksum, it's for error checking, window size, field used to indicate the number of bytes that can be accepted, window size accepted at one time, control bit used to include bit codes or flag which indicates the purpose, the control bit, the purpose or the function of this segment. Reserved, that is reserved for future use. We have length data offset that indicates the length of TCP segment header, the length of TCP. Then acknowledgement used to indicate that the data has been received. Sequence data reassembly purpose destination. Now this is the application destination, application port number, and then the source application number. So TCP handles all tasks associated with dividing data streams into segments, providing reliable controlling data, providing reliability, then controlling data flow, and then reordering segments. That is the TCP. So TCP here, these are the application that serves or that it works with. And then of course it doesn't work alone. It needs this IP address. So all these are now with this one here, as you can see, HTTP Hypertext Transfer Protocol for web browser, displaying the web pages, file transfer protocol for transferring files, transferring files, the files, simple mail transfer protocol for pushing mails. Then we have secure shell for remote access, secure shell for remote access. So all those are under TCP. In case, let's say, you ask the IP, the packets, the protocols that are supported by TCP, you don't need to mess. So any protocol that deals with dividing data stream into segments, protocol that deals with providing reliability, controlling data flow, reordering. So those ones are under TCP. Then we have UDP features, that data is reconstructed in order that it was received. So if you send 1, 2, 3 and you receive maybe 3, 1, 2, that is how it's going to be displayed. Any segments that are lost are not resent. So if you send 1, 2, 3 and you receive maybe 2, 3, the one it's going to, it means that it was dropped, it got lost. Then there is no session establishment. So if A wants to communicate with B, there is no need of first checking whether B is online or is available or not. A will just send. the sending is not informed about resource availability. So this A here, now that there is no central establishment, it won't be able to tell that the receiving device has enough resources, resources like enough RAM, like enough processor. It won't tell, it will just send. If it can't manage, then that is it, it will not receive. It will receive, but it's not going to process that. It's not going to process the data. So now look at the header. The header here, it is more complex. That's a reason why it's like it is fast. It's fast in sending because there is little or there is less or few fields to be checked. In that, it quickens the message or the performance is high. So we have source, as you can see, source, destination, then we have the links of the header, and then together with the checksum for error, then application layer data or the size, the window size for what to send on the destination. So we have here lengths, indicates the lengths of UDP datagram header. Then we have checksum for errors. Then we have source and then destination port number. Source application and then destination application, still by port numbers. Now, the application that uses UDP, we have DHCP. Now, this one here, it cuts across DNS, because let's say you're asked, it cuts across. There are those applications whereby they need the application that they would give DNS application where they would give the acknowledgement and blah blah, all that. Reliable. So it cuts across. So in this, we have DHCP, we have simple network management protocol, trivial file transfer protocol, and then we have voice over IP, then video conferencing. All those are UDP, supported by UDP, UDP transport protocol, but still it doesn't work alone. It has to work with the IP address. So port numbers, because the port numbers are the ones that uniquely identifies the protocols, sorry, the applications on the sending and then receiving device, or the source and destination applications. So UDP and TCP transport layer protocol use port numbers to manage multiple simultaneous conversations. So the source port number is associated with originating application. So the application at the source, it is associated with the port number on the local host, whereas the destination port number is associated with the destination application on a remote network, but still with the, so they are here. The destination port number is associated with the destination application on a remote network. So application, the application is associated with the port number, and then thereafter it can be the source or the destination. So what we need to notice is that the application, it is always attached or associated with the port number, and the combination will be source application together with the source port number. So as you can see, they are here. This is what we have there. Then we have what you call socket pair. Socket pair. Now, the socket pair, it is the two port number. It has to be port number and then the IP address. And then the direction. Now, we have what you call source and then the destination. So the combination or the socket pair, it's the source. Okay, we can go through the slide. That the source and destination port number are placed within the segment, So the segments are then encapsulated within the IP packet. So the combination of source IP address and then source port number, or the destination IP address and then destination port number. See that? Combination of source IP address and then source port number, source port number, or the other direction, the destination. The destination IP address and the destination is called a socket. So a socket, it enables multiple processes running on a client to disguise themselves from each other, and multiple connection to a server process to be disguised from each other. So there is no way we cannot have multiple uh, the multiple processes on either the source and then the destination to always be one. We can have multiple but connecting to different destination, but we can't have multiple on the source and then multiple at the destination with the same application. Like you having, I can give an example. Um, the example I'm going to give is email. This is the web browser. This is my email. This is my email. It's loading. Loading internet is not all that fast, but it's going to, I'm sure it's going to load. So if it loads, taking long. Okay, so we have this web browser. I'm think LS, I don't know where they are originating or coming from. This is my account here. So if I try to open again a new tab and put gmail.com, it should take me direct to this. It should take me direct to that page again. Yeah. But internet is a bit slow. What I'm trying to mean is, like, for example, let's assume that you have Facebook, Facebook page here open, and then you try to open it the second time, it will give you the same. It will give you the same page. It will give you the the same page. Eh? So we cannot have multiple. Mm? Multiple that they are different, that you have different here and then the other one, no, it will, that one, it won't happen. But you can have multiple connecting to different different destinations. Like Gmail, you have Yahoo, you have WhatsApp, you have Facebook, you have, you see that you have multiple sessions but uh, connecting to different destinations. So on this we have, as you can see, this is destination MAC address, this is the source. We have source IP, then destination IP address, but we have the ports. See that? We have the ports. That actually we can have this the same, but when it comes to the source port number and destination port number, and then this one here changed completely. But if this one here change completely, then we expect even the user data also to change. Yeah. So here maybe this one here it's for Facebook, and now if this one here changes to something else, it goes to maybe WhatsApp, maybe another one goes to different thing. So that is our source pair, what it does. So when you look at what we have here, the app, we have FTP app, which is 21. Then we have web down, which is this. This is the destination, this is the source. So that is the role of the port number, the sockets to uniquely identify the packet, uniquely identify the, the sessions So the transport, the transportation, so the ports or the center, they have to be different. So here we have the port number groups. We have port groups, then the range, and then description. So we have from 0 up to 1023. These are well known. They're well known, and these well known, most of the time, they are available on the server, on the shared devices. That every application that is installed on the server, it has to have the well-known port number, port 80, port what, port 21, 22, 23. Although they are well-known, port 144, 443, all those in that range. Those are port well-known port numbers. We have the registered port numbers. Registered port numbers, this is in case, let's say you want a port number to assign or to include it within your application. So you just go to Diana and then they reserve for you the port number, register it, and then you use it in application so that whoever installs that application, be it on the server, then automatically it has to uh, open that port for that application. Then it ranges from 1000, it's a continuation. You add the one here, it comes to the 1024 up to 49,151. Then we have what you call private or the dynamic. So these ones here, they are dynamically generated and mostly by the end device. The end device. So on our machines, every time they are trying to uh, attach the port number on the application, the source application, then it is auto-generated. The auto-generated one starts from 49,152, then to 65,535. These ports are also known as um, the private and then the dynamic. So the client's operating system usually assign those port numbers, dynamically when a connection to the service is initiated. So it's auto-generated. So whatever that is used today, it may not be the one to be used tomorrow. It's auto-generated. Yeah, so those are the three groups, port groups, well-known, well-known, then registered, and then the private. So some of the examples of the well-known port number, we have the port number, the protocol, the transport protocol that supports that port number, and then the application. So we have this 20 and then 21, that is file transfer protocol, one for data and then the control. 22, it's secure shell. 23, it's telnet. 25, that is simple mail transfer protocol for email. So as you can see, all them TCP. Then we have 53, which is DNC. We said it cuts across, it's both UDP and then TCP. 67, that is DHCP, it's UDP. 68, we have the server and then the client. So 67, it's the server. 68, it's that. And then 69, it's Strivo. 80, it's TCP now, Hypertext Transfer Protocol. 11, this, it's TCP, which is Post Office Protocol. Post Office Protocol version 3. We have 143, which is IMAP 143. IMAP, we have 161, which is Simple Network Management 161. Simple Network Management. Then 443, which is Secure. Hypertext Transfer Protocol, Secure, HTTPS. So those are examples of well-known port numbers. The net start command, it will actually, TCP connection can pose major security threats. So net start important tool to verify the connectivity. So in the connectivity, how it is connected, and then how the okay, it will show you the net start. It will show you the IP address, and the IP address, and then the port number attached there, and then the foreign address. The foreign address now, which will be like the destination. Then of course with the port. So it can be port number or it can be port name. So this is HTTP, HTTP, HTTP. Still this one here, it is domain, still with HTTP, and then even this. And then we have the established. The established, it means that the request sent here, it will be allowed to go back to that IP address, meaning that they are going to be maintained and this. So when the reply comes back, now this will be the source port number, and then the destination will be this. So TCP communication process, so we've already explained that each application process running on a server, it is configured to use the port number. It's a must, it has to be there. So an individual server cannot have two services assigned the same port number. That one will never happen. So an active server application assigned to a specific port is considered open. So once the service is assigned a specific port and it's active, then it is considered active, meaning that it can meaning that the transport layer can accept uh, requests, and process those requests addressed to that port. So any incoming client request addressed to the collect socket, it will be accepted and it will be passed to the server application. So as you can see, so we have this link here for client 1 and then client 2. It's the same server, but we have different clients. So one, for this one here, it's HTTP, and then when it comes to this one here, it is simple mail transfer protocol. Simple mail transfer protocol, but originating from different clients. So TCP connection establishment, of course, for the two devices, the source and destination, to communicate together under TCP, then they have to establish the connection. And there are 3 steps: step 1, step 2, and then step 3. So step number 1, the sending device, it has to initiate client request to client server. Client server. So this one here, it has to request, initiate the session. And then PCB, it's going to, the server, it's going to acknowledge the client server communication session, and then the requests server to client. Now, this is the one requesting, and then this is going to reply. And then at the same time, now the server has to also initiate, the connection too. It is there. Now this one also, it's going to initiate and then A replies back. So that is what it means here. And then after that, they will establish the connection. Session termination, still it is the same. 3-step, because the other one was this 3-step. It requests, then gets the reply, and then at the same time also requests, and then gets reply. So it is the same here in the termination, as you can see, that if there is no more that is needed to be sent on the network, then A is going to send finish flag, and then B replies it. And then again, B is going also to initiate the finish flag, and then gets acknowledged. and then the session is going to be terminated. So TCP three-way handshake analysis, functions of the three-way handshake, it establishes that the destination device is present, verify that the destination device has the active service that is needed in that process of connection establishment. Service and then is accepting requests on the destination port number. So it has to first determine or notice that the destination is active and is accepting the requests. Um, with this, the three steps, it establishes the connection with the destination, make sure it establishes that the destination is active, is available, and then it verifies that whatever that is needed, it is available with the service, it is active on the destination device, and then after that, it informs the destination device that the source client intends to establish communication session on that port. So after the communication is complete, then the session are closed. So once whatever service that is needed, or maybe the source has access to the service on the destination, then the session it has to be closed. So in the three-way handshake analysis, there are 6 control bits. We talked about the control bits for controlling the three-way, the termination, actually the termination, it's the session establishment, then even the termination. So there are six control bit flag where we have urgent, acknowledgement, push, rest, synchronization, and then finish. Depending on what is it urgent, then it will be is it an acknowledgement, it comes in. Is it a push function, then it is turned on. Is it a reset, it is turned on. Is it the synchronization, initialization, and then it comes in. And then finish flag, it's the one that will be, if the finish is to be used, then that one it comes in. So this is a video that covers the following: TCP, three-way handshake, then termination of TCP conversation, reliability and flow control. Reliability, to make sure that the session is reliable, and then the flow control, what is to be the session. So we have guaranteed and then orderly delivery. So in this guaranteed and then orderly delivery means that all the 5, for example, this is data divided into 6, and then the 6 they have to be received on the destination, and on the same time they have to be ordered. So when you look at this, because they're different, multiple routes, this, this, the other one, and then this, so it means that there is a possibility that by the time the destination receives, they will be out of order. That's the reason why you're seeing these arrows. But still they have to be ordered so that they look uniform the way they were sent. Then here there is a video about sequence number and then the acknowledgement. The acknowledgement. You just play a video, it will guide you. Then still under TCP reliability, we have data loss and then retransmission. It's possible that any data, it can be collapsed uh, along along the transit or along the way to the destination. So what should happen? So the data loss, it should be retransmitted. So as you can see in this, the first one, we have 1, 2, 3 sent actually up to 10, but 3 and 4 have not reached. So what is going to happen? That this, it's going to acknowledge the sent 1, 2, 3. It will start there. They acknowledge that, and then 3. We have 3, 4. So these ones have not been received. They have not been received. So if they have not been received, then automatically they are going to be retransmitted. But in that process of retransmitting them, now it has retransmitted this and then this, but from 5, which was already the other side, already received the other side, they are also again going to be retransmitted and then end up getting duplicate segments. Duplicate segments. And then now, this time as they have been received, now we have acknowledgement as 11. So the acknowledgement, it's just an incremental. We can't start the acknowledgement also to start from 1. The acknowledgement, it has to be the increment. That if I send 1, 2, 3, I expect the acknowledgement to be 4 because it's a continuation. Yes, I've received 1, 2, 3, so it's 4. It's an increment, an indicator that I've received these other sequences. So TCP provide methods of managing these segment losses. Among these is mechanism to retransmit segments for acknowledged data. So with that method, it's actually resource intensive. Then it lowers even the perform network performance. So we have what you call the host. The host operating system today typically they do employ another mechanism, an optional TCP feature called selective acknowledgement. That instead of acknowledging selective acknowledging negotiated during the 3 handshake. So if both hosts support selective acknowledgement, then the receiver can explicitly acknowledge which segment or the bytes were received, including any discontinuous segment. So here it's only this and then this that we did not reach. Now that there is this selective acknowledgement, now it will, again, if they to transmit, it's only this and then other that I need of that are to be transmitted. So here it's 3 and then 4. And then 11, as you can see, we have 11 and then 12, which was not sent here. But in transmitting the segments, the unacknowledged segments, then extra segments were added, which is 10, which is 11 and then 12. And they are also acknowledged separately. They are also acknowledged separately. So here, the acknowledgement, as you can see, we have 3, the selective, that we have 3, because we sent 1, 2, then 3. Then we have from 5, 10. 5 to 10, they are also acknowledged. And then we have this 12, and then this also acknowledged. The video data loss and then retransmission, still it will guide you there. Then we have what you call the flow control. Flow control, still, okay, window size and then the acknowledgement. The size. So TCP also provide mechanism for flow control, as the flow control is the amount of data that the destination can receive. It's not what the source can send, but what the destination can receive. So that destination, what the destination can receive, it takes or it happens or it is actually debated on the step of tension establishment. Tension establishment. So the flow control lets maintain reliability of TCP transmission by adjusting the rate, by adjusting the rate of data flow between source and then the destination for a given session. For a given session. So of course there will always be window size. Now the window size, this is what the destination can manage. But of course we have the segment size, or what is supposed to be sent per segment. So we have what called here the maximum segment size, the maximum segment size. So the window size, what this one here can, uh, what the destination can actually uh, process, it's the window size, which is this 10,000. But per segment, we expect the maximum segment size, which is 1,460. So for each, for each. So as you can see here, we have what 10,000. It is what B can uh, process, what it can manage. So the sequence numbers, when it comes to the segment, they will always contain this. So if we send this, it's from 1 up to this, from 1 up to 160. Then the second one, now it will be this times 2. So you get this plus this, this one here, plus this, you will get this. And then the acknowledgement, you have to add the 1 because we can't acknowledge exactly this. So if we add 1, the acknowledgement is this one here. But still we have an indicator or indicating that this PC, it can manage this. And then this one here, it's going to add, as you can see now, it's the continuation that this sent this to this, it totals to this. Now it's a continuation, it adds a 1. But if it adds a 1, it's for the sequence number. And then on this, we're going to add this one here. So this plus this, you will get this. And then the acknowledgement. Now the acknowledgement here, we have to add the 1 here. That is what you're seeing here, the acknowledgement. But still there is an indicator that it should not exceed this. So the segments that are sent, they should not exceed this. So if it received this, then it will process the window size. So still the same on this, it's a continuation. It's a continuation. So this window size, it is always debated on in the process or during the three-way handshake. So maximum segment is the maximum amount of data that the destination device can receive, what it can receive. So common, it's this it's this when using IPv4. So a host determines the value of its maximum service, maximum segment size field by subtracting IP and then TCP headers. The TCP headers from Ethernet maximum transmission unit. So which is this one here, bytes by default. So it will be this minus 40. So out of 40, we have 20 bytes for IPv4 header and then 20 for header, and then leaves it with this as the maximum segment unit. Then we have congestion avoidance. When congestion occurs on the network, it results the packet being discarded by the overloaded router. So to avoid and then control congestion, TCP employs several congestion handling mechanism, then the timers, and then the algorithm. So what is going to happen if you have segment 1, 2, 3 sent 4, and then the acknowledgement it is only 2. The only 2. So at the time when this is going to be retransmitted, then there is a possibility that the window size, this side, the window size, or even the maximum segment unit size can be reduced. Can be reduced. So here I'm not getting the acknowledgement I expect from PCB, so I will reduce the number of bytes I send before getting acknowledgement. So UDP communication, it does not establish connection. It provides low overhead data transport because it has small datagram header. You saw they were large, just just for source, destination, and then we add checksum. What was this? Checksum, I think, with the say something like that. Four fields. So the UDP datagram reassembly, UDP does not track sequence numbers. That does not track sequence numbers the way TCP. It does not track. It does not sequence number the same TCP does. It doesn't. UDP has no way to reorder the datagram into their transmission order. UDP simply reassembles the data in order it received them and then forwards it to the application. So it's here. So if you're sending all these and then maybe reaches this, as you can see, 1, 2, 3, 4, 5 instead of 6, the other ones that have reached. So it's not going to retransmit. And it will present the way they are in that order. UDP based on server application are assigned well known, so it also uses on the server side, it uses the well known or the registered for new applications that are coming on board. UDP receives datagram destined for one of these ports. It forwards the application data to the appropriate application based on its port number. So the port number function in the TCP remains or functions the same way in UDP, or UDP port numbers function the same way as in TCP. Then we have the UDP client process. UDP client process, it operates the same way as TCP, TCP in terms of port numbers. In terms of port numbers. So the application, they are clearly identified at the source and then at the destination. And the destination is not permanent. So still server, if the server is replying back to the client, the server, it becomes a source and then the destination. But on the port numbers, that the server most of the time it has, actually not most of the time, but it has the application at the server, they are assigned with the well-known port numbers. Then with the clients, or they do have port numbers at the client, sorry, at the server, together with the registered port numbers. Then when it comes to the client, those are the dynamic or auto-generated port numbers. I think that is the end of the session. Thank you.